On behalf of Electrical Engineering Department, SCET, and our entire team of FDP, I warmly welcome our eminent speaker, Dr. Premalata Jena. She is an associate professor at Department of Electrical Engineering, IIT Roorkee. She has completed her PhD and MTech from IIT Kharagpur. She has more than 20 years of teaching experience. Under her supervision, more than 20 theses and projects are completed. She has published more than 50 papers at various journals and conferences at national and international level. She received many awards and honors at national and international levels. Today, she will share her experience on Introduction to Smart Grid Technology. Madam, we are delighted to have you with us. Thank you. Over to you, ma'am.
Okay, so my voice is audible?
Yes, ma'am. It is audible.
So thank you so much. First of all, a very good afternoon to all of you. So I request please mute your mic if possible. I mean, so that we can, even if possible, we can also switch on a video so that the interaction will be better. Right. And the so from my side, I'm really thankful to the whole team, SCET, SCET, and the title of this particular event is Microgrid: A Path to Sustainability for this period 20th December to 24th December 2021. So this topic is very timely topic, and so I found that as from IIT Roorkee Electrical Department, my whole team, my PhD scholars, MTechs, BTechs, and many of the faculty members from our department, actually we are basically doing the research and teaching in projects, and also involvement with the industries together. So I felt very happy to be part of this. The event. So I'll just share my PPT first and tell me whether it is visible or not, and then slowly we'll proceed. Is it visible, my PPT, to all of you?
Yes, ma'am, it is visible.
Okay, thank you. So I'll bring to the full mode screen mode. Is it fine, the full modes? Like presentation. Is it in presentation mode?
No, yet not.
No, it's not yet.
Okay, so actually this is, I felt this is the problem in Google Meet. Very often I have delivered in many other points also. There actually the full mode screen doesn't come. Maybe, I don't know. Shall I proceed with this, or
Yes, ma'am. You can proceed.
I'll proceed with this?
Yes, yes.
Okay. So thank you all the participants, and I request you can interrupt in between if you like. This is a very normal, casual, abnormal platform. Very non-formal, you can say, discussion. You can always join with me. You can interrupt in between, and there is no restriction from my side, at least. You can interrupt me anytime if you like, where you have some queries, some discussion you want to do. And mostly this topic is very much research oriented, and just the introduction part I'll cover initially, and then I'll tell you, as the topic is microgrid, this particular FDP session is on microgrid, so I'll just tell you what is microgrid, what is mini grid, what is nano grid, and what kind of some little bit thought process, if time permits, on protection challenges. And because our team here, we are focusing on mostly the monitoring, control, and protection challenges on microgrid, both AC, DC, and also we started with AC, DC, then electric vehicle presence, and electric vehicle charging stations, battery storage, everything. So if you see this particular word, sometimes I also, when I was in a initial stage, starting our journey, like before 10 years almost. So I was just coming across this word. What is it? And after onwards, we'll understand what is microgrid. If you'll not understand the point, what is smart grid, perhaps our idea will not be clear about this microgrid word. So therefore, I'll just try give some motivation that why this smart grid is needed in today's state. Not only in India, it's a concept, it's a ongoing like research and revolution, you can say, throughout the world. So coming to this Indian context, what is the meaning of this smart grid? Why this smart grid is needed? What is microgrid? So I'll just tell you one by one. So this is data I have collected, and I have to also rectify in favor of Electricity Authority of India. This figure has not been captured. I mean, we will also revise this. But however, this data is for 31st March 2020, that our installed capacity in India, the power generation, is 370
Madam,
gigawatt.
excuse
Yeah,
me, ma'am. And you are, I think, on slide number 1 only. Yeah, now it is visible.
visible? Good.
Now, okay, now it
Fine.
is visible. Huh.
Fine. Thank you. Thank you so much. I think it is not scroll down, right? So in this
Yes.
Google Meet. Yeah. So is it visible properly to all of you?
Yes, now it is visible.
Good. So this value, this 370 gigawatt, it's now we are planning. The India government is planning by 2040. This figure is going to be more than 500 gigawatt. So this is one fact, or this is one prediction, not prediction. This is the real demand. Okay, and by 2030, the India government has planned to add more than 400 uh, gigawatt of renewables to the existing network. So this sort of information, this is all available in the website. But what is the very point? Where is the problem? So this figure is okay. So India government is planning to add uh, or generate more than 500 gigawatt. That is obvious thing, because all together India is now developing, and our Make in India concept is going on, and our generation mostly from renewables should be very much clear, vivid, and the demand from the customer side is quite high in all the sectors of load sectors like industrial. I generally start from residential, then you have agricultural, then we have small scale industry, large scale industry, then we have also our transportation load sectors, which is one of the important discussion nowadays, that very soon we are going to add the electric vehicles to the existing circuit. So, in that sense, every sector, this load sectors, our demand is increasing exponentially. So, if it is increasing exponentially, so the supply should be also ready, right? So, if the supply is not ready, so of course, somewhere we'll miss our critical loads, even it is non-critical loads. So our per capita consumption is very very less. This figure I have not collected. You can also see in the website. The per capita consumption of energy in India, in comparison to other developed nations, are very very low. So it doesn't matter, the per capita consumption is the one target, but at the same time the major target is what I have kept in front of you, this PPT. That if you see this pie chart, the maximum pie chart portion is covered by the coal generation, that is around 55.4% or 60%, you can say. So this coal based generation is one of the major worry for all of us, and we have to certainly reduce this generation. And in case of India, our renewable generation for the time being, it is around more or less within 30%, and it is shown here by 2020 23.5%, except the large hydroelectric generation. So now the good part here is we are always dependent. India has a very lot of plentifully available hydro generating stations. From the mostly in the northern side is highly rich in hydro generating stations, And there also the government of India is planning to have small, I mean, there is a mission for small hydro power plant very soon, mostly on the northern side and not necessarily in that southern eastern region, so where we have good amount of hydro facility. And so we have to basically tap those stations for small hydro power plants as well. So this large hydro and small hydro power plants together, they come under the renewable energy sector or segment. So this large hydro in India, we have generation up to 12%. This blue one and the green one is the renewable source. And we have also 6% gas generation, nuclear, diesel. So for your information, the coal, which is one of the our richest or our major asset for all of us, that our coal-based generation should be strong enough, and that should not move not more than a decade. So, and not only that, and you have seen a lot of pollutions, lot of discussions, carbon dioxide footprints, so many restrictions from the Eastern, I mean, international agencies, international forum. So there is a forum, so there is some restriction how much every country can produce the carbon dioxide, emission. So there is a restriction on that. So therefore, it is very essential. Almost all our industries, not only the energy sectors, but also other industries, they are going to tap the power from the renewable sources. So this is a very important discussion for all of us. It is not that this microgrid, smart grid context, but this point should be noted down that we cannot wait anymore. We have to definitely harness most of the energy from the renewable sources. So this is one of the figure, one of the status I have kept in front of you, that how we can basically this green portion will dominate the brown portion. So that should be the green and blue portion should dominate the brown portion. That should be our first target. So this is how the renewables, as I said, the renewables generation is must. There is no compromise for this. In India, we have a very good target already. I have said before few minutes that 2030, our renewable generation will reach to more than 400 gigawatt, which is basically more than our installed capacity. So therefore, we have to very strong technology for that. Just talking like this that India will generate, it is not possible. So we have to be also very strong regarding the technology, its design, planning, implementation. So then only that amount what we are talking in paper, so that will be in real application. So this figure already which is implemented, I have kept in front of you, that is by 2020, the renewables which are actually generated, it is 87 gigawatt. And our target by 2020-22 is basically in the range of 175. Already we are reaching to that age, that is 2022. But as I said, by 2040 or 2030, so our target will vary within 400 to 500 gigawatt range. So this is the scenario of our renewables generation. Like the first the position of the renewable source is wind in our country, and next is solar. That is, wind is around 45%, and solar second position, 36%, biomass, small hydro, and waste to power. So these are some of, the major backbone of the renewable sources. I mean, if we talk about the renewable sources in India, so our major backbones are wind and solar. And now we are just going towards solar energy, right? So therefore, what I'm trying to say, it's a kind of massive change has been drawn, or it is already very clearly you can see even by yourself also, nearby cities, nearby villages, even nearby urban areas. So there also the rooftop mounted solars are also very clearly, they are coming up in a very bigger scale. So And that is also one solar DC electrification of rural areas that comes under rural electrification section of the Ministry of Energy of our country. So they have taken a charge like how to electrify the rural areas using the solar electrification process. In fact, before few days, I was discussing with one of the company. They said they have taken up the project from few villages in Uttar Pradesh, and so they are trying to have some rooftop mounted solar panels, battery storage, then how they can supply the power to the household equipments, and at least lighting, DC electrified lighting systems, DC fans, DC chargers. So how they can supply to those few loads from this solar rooftop mounted system. So these are some of the very good initiative by many companies and also our industries, and they're also trying their best. They're just trying their best to how to compile, how to reach to the goal at the optimum point, and how we can help as a researcher to them. That is also one question. So if any problem comes, any sort of, let us say, some opportunity will get during our research process. So definitely we should help them to overcome such difficulties, what the industry people they are facing. And in fact, I also came across of many industry people that they are taking the components from different, different organization, and from there they are just combining together, and then they are just selling to the parties or customers. So that should be stopped, right? So let us say they are taking some components from China, they are taking some components from Thailand, they're taking some components from US, wherever. So they're just assembling those components and they're selling to the country. So in that front also there are so many initiatives have been taken by DST, that is the Department of Science and Technology of our nation. And also there are so many boards where we are trying to have some own technology and also convert those technology to the product form. So if you can do some small contribution, even let us say the Tata Power is making the solar panel. In our IIT Roorkee campus, we have rooftop mounted solar panel. Initially, it was 1.8 megawatt. Now it is around another 2 megawatt of solar panel already commissioned, and it is installed on the rooftop. So around 4 megawatt of solar energy already we are getting from the rooftop, solar rooftop mounted systems. And our demand is around more or less 8 megawatt. So 50% of those, at least the power for lighting purpose, for cooking purpose, for heating purpose. So we are getting at Roorkee campus is getting from solar. So these solar panels which are installed here, so they are actually manufactured by the Tata Powers. And again, the inverters which are actually installed, I could say, or I may or may not say, I don't know, but they are not necessarily they are manufactured in India. So why not we have to try from our end together, all the researchers from every corner of our country, like IITs, NITs, government colleges, private colleges. If some pioneers are there in the research field in this direction, they should come forward and make their own contribution. So this is a small contribution also makes a lot of difference to the system. We should not see that, we should not think how much I can contribute. So that should not come in mind. So there is always some opportunity everywhere. So this is how the India government is trying, and everywhere we are trying to push the solar based supply system, because the wind has a constant, like you can just put in a particular area, so where it is windy and you have sufficient lands, and also the structure should be very far away from the community, specifically from the human community and the animal birds community. So then only it is possible the big towers we have to install. And unfortunately in many states like coastal based, states like eastern side, western side, and southern side, we could not tap that much of power from the wind system. But still a lot of possibilities are there. That map I have not shown here, but I do have that map where we have a lot of potential areas as far as the wind and solar is concerned. And the third most very promising renewable source is our waste product. So we have lot many biodegradable products where easily we can generate the energy from out of it. Okay, so we are wasting a lot of bio products. So from there, so we could have a very good opportunity to access the to produce the electricity. So this is a one more information I want to share regarding this generation capacity, how it is growing throughout the our, I mean, worldwide. What is the installed capacity of power, and what is our generation capacity, where we are standing globally. See, when we are talking India, that is incomplete. So we have to also stand. The reference is the global platform. So there, the India is competing. So when we talk about some state, the state is competing with the nation. So similarly, the nation is competing with the world or continent. So therefore, it is very essential we should know in the world front where India stands, and what is India's capacity, and how the generation is possible. And so similarly, so many other options are there. So where we can have a good amount of tap from the different places. So worldwide, the capacity is, you can see this, that our capacity, existing capacity is this much, and the new capacity which we are going to add, it is almost a kind of value is almost it's going to, existing capacity is 3000 gigawatt, and it is going to be around 7000 gigawatt, more or less 7000 gigawatt by 2030. The existing capacity is I mean you can see it is going to be double of that very soon, so, or more than that even. So that amount of energy we need. So existing platform, you see, it is very less, 3000 gigawatt. So we have to add more energy. That means the our whole world, it will see a very great change, and we have to add at least more or less 4000 gigawatt of energy together. And let me tell you here, that picture I have not said here, but mostly the third world country like Indian, this Asian continent, the nations including India, so they are actually having the deficient of energy. But however, China and all, they are saying, they are declaring that they are well sufficient, they are developed, they are having sufficient energy margin for supplying the customers. But still, there is always a need of supply power from the not coal based system, rather from the your the renewable sources. There is always a race among these two factors, how to just overcome the power or access the power from the renewables, not from the non-renewable sources like coal-based generating stations. So now this is one picture, very clear-cut picture I have kept in front of you, that why this is important. And I have not still came to my point where I started from the beginnings, smart grid technology. I'll just share with you quickly. So after maybe 2-3 slides, you'll come to know why this smart grid is essential. So first picture I have kept, what is the energy trend and what is the Indian standards in renewables front. So see, next one more important motivation for this smart grid, that is a number one drive. The drive number one, we have to add more renewables to the existing network. That is must. So therefore, we are moving towards smart grid, because renewables are very much intermittent in nature, very much stochastic. I mean, they are very unpredictable. So today you have solar generation sufficiently you have in your hand, but tomorrow due to some fog or some rain, so you may not get the solar generation properly. So they are very uncertain. In the through the day also, the sunshine, the irradiance, we call it as solar irradiance, that we measure with watt per meter square, solar irradiance, that varies from morning to evening. So this sunlight light, that intensity also varies. Now when the intensity will vary, like sun's irradiance, let us say from 100 to 200 watt per meter square to 1000 watts per meter square. That is our standard, the last one. So the generation also varies. So this is how the solar is very unpredictable, uncertain, and also the wind is also very uncertain because wind speed also varies. Sometimes in seasonal wise also wind speed varies. So therefore, these sources are very, very uncertain in their generation pattern. So those, I mean, if we are going to be our customers, our system is going to be dependent on those sort of uncertain sources. So our system should be very strong, and therefore the smartness has been developed. The smart grid we are talking, that is the one driving force which leads to the smart grid technology, is how we can handle such huge uncertain renewable sources to the network. Even though they are very helpful for us, they are renewable in nature. There is no end to the sun, there is no end to water, there is no end to wind. But at the same time, we have also certain very big, I mean, task in front of us. They are very uncertain. Not only that, this is a big point, okay, and then we have lot many other issues also, like designing those components of the renewable sources, having low inertia concept, because now the renewable sources, the main heart of renewable sources are the converters. So when the converters are basically, present more in number in the circuit, the inertia of the system will reduce. So there are so many uncertainties. Slowly, when somebody will go in deep, stability, protection, control, so every aspect, communication, infrastructure. So those for renewables, we need some smart technology. Then the driver number one, and second one, the last, if someone of you from are from the power system background, or you may have gone through some report from our POSOCO, that is one of the power system company of our in country, uh, Power Grid Corporation of India. So they are responsible for our transmission circuit network. They are owned for those transmission circuits, the Power System Corporation of India, Power Grid Corporation of India. So what happened in 2012? There was a blackout, and this and that time what happened? Why this blackout has happened, and how it is connected to this course context? You may ask, you may think that why this topic is, how it is related to this topic. Yes, there is some link to our topic. So the point here is in 2012, July 31st, so there was a big blackout. Now, first of all, you may understand what is blackout, and then you'll understand what is big disturbance, large disturbance, and then we'll understand how this thing is linked to our context of our topic. So there was a four, just in short, I can tell you, because due to the time constraint, there was a link between northern side to western side. There was a 400 kV double circuit line was running from your western side to northern side, Bina to Gwalior. Bina to Gwalior. So you can read more. These reports are available in the POSOCO, the Power Grid Corporation of India site, and also you can download so many reports has been made by the many task force and some engineers. So this line was heavily loaded suddenly, because the northern side customers, they there are some Diwali, some sort of kind of celebration, and some due to the high loading of those that particular 400 kV line, that was a double circuit line, there was a tripping of the circuit breaker. So this heavily loading condition, we call in electrical engineers, we call it as load encroachment problem. And that line was heavily loaded. So this load, I mean, that heavily loading, due to the heavily loading of the line, and that one of the distance relay zone 3 has been tripped. So those distance relay, I hope many of you, I mean, do not know, because maybe power systems people, they understand. I mean, it is actually one device, relay or protective device, you can understand in that way. So this distance relay was mal operated, because there's no fault, no other scenario, fault scenario. But however, due to this overloading of the line, it has been tripped. So due to tripping of one line, other line was overloaded. Then that other line also was heavily loaded because it has to carry more power, and then that line was tripped. Suddenly, in that way, your many lines are overloaded, and this is known as cascading failure of the lines. So this is known as how the disturbance has been propagated inside the circuit. One by one line link will be lost, and when the link is lost, then of course what will happen? Our or we have five national grids: northern grid, northern eastern grid, western grid, southern grid, then eastern grid. All five grids are interconnected. So now, due to the failure of these links, and slowly our disturbance has been propagated inside the circuit. And what happened? Basically, our western side is the consumers. They receive power from the northern side. The northern side was supplying the power. All the hydro stations are on the northern side, and hydro station has synchronous generators. So there is a mismatch between electrical power and mechanical power. So, however, this mechanical power in the synchronous generator sides, they are constant, and other side electrical power was actually cutting down, and it was less. There is a mismatch between the electrical power, mechanical. It leads an accelerating power, so which lead towards the shutdown of the machines, generators, or shutting down the power. So balance it. In that sense, the synchronism has lost, and there is a blackout condition. So in that sense, what happened for 2 days, there is a big loss in our economy. If you think 1 minute, if there is no current, no power supply, no light in our home, so we are just mad. We will call to the nearby substation, nearby electrician, or why this power is not coming, what's the problem, those sort of things. But when there is some operation is going on, some hospital, some airport is takeoff is going on, whatever the operation is, very essential operations. I'm talking about regarding the very critical loads, metros, trains, whatever. So many process industries, and so there we cannot compromise the supply for a fraction of a second. Okay, so you forget the 2 days. That is a very big deal. So that is the scenario which creates problem for human life, or loss in our economy. So that in that case, how to solve this problem? If, let us say, that relay the center could have been intelligent, smart enough to predict that there is some blackout is going to happen. So maybe the operator could have sensed, or some other means of smart technology could have been placed, and it could have been sensed this is the problem which is going to happen. It had been, see, this process is a slow process. If it could have been sensed properly, and we could have stopped those such big or large disturbances. So few persons will be affected. Maybe those persons which are not affected, they will be in healthy states. So there are so many concepts are going on in this front, like islanding. Like some areas we have to island from the main disturbance areas, and we have to restore back slowly. So these are some of the smart technology. And due to the lack of those smart technology, so we got such sort of major disturbances. We call it as blackout. So in this sense, in this context, this is also second driving force, that why we need this smart grid technology. And the third concept where I want to share with all of you, that we are talking presently in present system in our circuit, we have a whole all over India, we have AC circuits, isn't it? Our main supply is AC. Even today, at the distribution level, transmission level, generation level, we have three levels of power supply. So every supply system is having the AC supply, AC sockets, okay, and AC voltage, AC and frequency. But it is observed slowly from the research, it is observed that if you increase the size of the interconnected grid, then slowly the benefits, even though you will put more effort, but the benefit will be very less. So how to handle this? The benefits are very less, but my efforts are more, my cost investment is more, my effort is very high, but however, I'm not getting any benefit out of it. So this figure shows the cost to performance ratio figure on the right side. See this one. So this is my x-axis is the size of interconnected grid, and the y-axis is the benefits efforts. So this blue curve is the benefits, and this red curve is the efforts. So as you keep on increasing the size of the grid, then my efforts also you can keep on increasing. Then at certain time, my benefits are, this gap between effort and benefits are very less. So this will squeeze. So it indicates that we have to think something different out of it. We cannot go for a very large AC system. Rather, we have to go for a smaller circuits. This indicates one thing to all of us, that we have to basically target small circuits, small networks, where our benefits, our efforts are reasonable and our benefits are optimum. Okay, the size, if will be reduced in terms of voltage, in terms of lines, lengths, areas, distance, power handling capacity, every factor I'm talking. So that case, our efforts and the benefits, we need a optimum solution for that. Okay, so and not only that, we have, and this indicates the microgrid concept. From here you will get the microgrid concept, that micro means, I'll come to that point how it is. But however, from here slowly we can think of that what is the advantage of microgrid concept, and why this smart grid, everybody is talking smart grid, that is microgrid. There is some reason behind it, or just people are just saying namesake. Just they heard from somebody and then they say heard and somebody is telling. No, it is not like that. So it has a certain reason behind it, very solid reason, and it is mandatory. It, we have to understand and we have to move. And this limitations of large AC microgrids also I have noted down. Already most of you have gone through it, but still I can highlight few points, like the first and foremost thing is the oscillations and frequency voltage stability, and then also blackout risk due to the cascading events. Already I have discussed in front of you just before my this slide. And also interaction between the power systems in terms of physics. I want to emphasize on this point for 2 minutes, and I'll move to the next slide. So let us say in my village area, I have seen today also some wind, some natural disaster is there. Let us say some cyclone or something. So then the all the overhead lines are just down, right? So they're just broken and they're falling down. The point is, it takes months sometimes or weeks to repair those lines, and so that we can get supply in the village areas. So even then it is erected and it is corrected or it is maintained, but still the duration of power supply is very less. Maybe hardly we are getting 8 hours supply. In summers it is very less. So therefore that means, even though we are enabled, we are declaring that our electrification is 100%, but it is not 100%. Consumption wise it is not 100%. So if we make small, like any disturbance will happen at my home end, I cannot contact to the utility. That facility we don't have. I don't have that power to access the utility. Okay, so that is the major demerit. Okay, the current it will come. I don't know, somebody asked to some when it will come. Okay, so somebody has gone, so he'll report and it will come. So with a single phone call, with a single switch on message, that should happen. So this, because the distance is quite large from the load centers to the generating station, and there is no control of the generating station over the control customers, or customer has no control over the generating station. The distance, the mismatch, and the communication gap is there. So therefore, to overcome this gap, the distance, what we are thinking, the government has thought, many, not government, in the worldwide, many people, researchers, they thought, why will not go for microgrid system, where the power handling capacity will be low and area wise it will be less, and the customers can talk to the the utilities, the utility can talk to the customers. They'll have a good exchange of ideas, power, money, economy, whatever control so between them, right? So for this exchange between the customers and the the utilities, that is known as smart grid technology. How they can talk to each other, how the utility can control the customers utilization factor or can benefit the customers, and customers can also help in benefiting and maximizing the utilizing the assets of the utilities. So that kind of environment is very essential. So this is how the things move. And as I said that everybody, now we have a lot of option for mobile phones, SIMs, like laptops, any sort of things you see. The market is very very advantageous, a very you can reach to anyone. Similarly, the electricity market is going to be like that. Even the customer can also sell rest of the unused power to the rest neighbors or to the nearby grid. So this concept we know, we call it as presumers. Presumers means the customer can also be participate in selling the energy to the grid system also. This is a very big concept, but I don't think it will take some long time to be implemented in reality. I am sure because in many countries it is happening. So why not in India? India can also do it. So therefore, more or less, final figure in front of you that I came to my end of my first part. The why this, what is the meaning of smart grid? Then I'll come to the microgrid part. That we need some flexibility. We need some flexibility in our circuit network, in our behavior, in our economy, in our reliability, in a planning, everything. So we need some sort of satisfaction. So every end, this flexibility word is not meant for technicality. Technicality, obviously, technical situation is always there, but I'm talking in overall satisfaction. So this flexibility is needed because increasing this grid size complexity, we don't need anymore. Demand growth should be increased, increasing energy trend, changing the load flows, bulk power generate transmission, and bottlenecks, this overloads, and variable infits. So these are some of the thought process from my end. Okay, now so this leads to one, I mean, a very great change, Tom, we call it as this flexibility will drive, and it will help us to deliver efficient, reliable, secure. And one more word I would like to add here, it should be also sustainable. So we need an efficient, reliable, secure, and sustainable power supply. And so that is only and only possible if we can aim some smart grid technology. So that means the smart grid technology and the microgrid comes under the smart grid technology. The microgrid is a portion of the huge circuit, like just like a home, then some district, some state, then the nation, then the world. Similarly, the nanogrid, mini grid, microgrid, and the whole national level grid, it goes like this. So based on this information that many forum, they have defined what is smart grid. Okay, that smart grid word itself is nothing, it's a combination of information technology, communication technology, along with the electrical technology together, and with the high end sensors, controller. So the whole technology, which is actually intelligently, it is integrated to the circuit for efficiently delivering power in a sustainable, economic, and secure manner to the customers. That is what is the global smart grid federation says. Okay, so this is how the smart grid definition is. So sometimes the DOE, that is a Department of Energy of USA, it has also different definition. But however, if we combine all the together definitions, it stands only one aim. That is what, how we can reliably, efficiently, and timely, in a sustainable manner, we can supply power to the customers, keeping our everything intact without using any coal based generation, without using any gas based, nuclear based generation. And also we can reduce the distance, we can reduce the hindrance, the barrier between the customer and and the utilities, so that easily they can utilize the energy in a proper way for reliable purpose or economic purpose. So finally, every agency, every research, every industry, so they are trying to how much we can penetrate the renewable energy sources in a stable manner. As I said, renewable integration is not so easy. It takes a lot of challenging tasks at the different fronts: stability, protection, planning, then designing the controllers, everything. So there are so many aspects, challenging facts we have to carry, we have to take care before integrating the renewables. So therefore, this kind of study is always a vision, it is not a product. Okay, so we have to see in a visionary terms, and how we can just forecast our, you know, our energy trend and where we stand, how we can mitigate the problems, how we can give the all sort of problems. See, I can tell you, when we talk about, we think about our own, because our eyes will see only our technical aspect, but however there is social economic aspect also, how society will be benefited economically, and how, what, where will be our environmental aspect will stand. So everything we have to see together, right? So shall I proceed? So shall we take a pause here? We'll take some 5 minutes if you allow, otherwise with your permission I can also move ahead. I don't have any problem.
No, ma'am, you can continue.
Okay, fine, so I'll continue.
Yes, ma'am.
Okay, so maybe another half an hour I'll continue, and then we'll take the question answers.
Okay, ma'am.
Okay, okay, fine. Okay, so any queries from the participant side? So I'll be very happy. Till this first half, that was my introduction part to smart grid. If you have any queries, I'll be very happy to answer quickly, or some discuss, or some suggestions, or some corrections. I'll be very happy from your end. If anybody can unmute, and he or she can share something, what I taught, what I discussed till this point for last 1 hour. If you want to say something, you are most welcome. Yes, you can also chat, or you can unmute yourself, you can talk to me. Anything you can like, you can do. Okay, so no issues, let us move ahead. Right, so now I'll go for a little bit uh, deep to this concept of your title of your today's this FDP, that is the microgrid, a visionary step. So here, what is the definition of microgrid? Can anybody here? I'll put some. I hope that already a few days you spent, all of you, and if I'm not wrong, so a microgrid, a path to sustainability. So can anybody share his thoughts? What is microgrid? Anybody just can open your mic and share your thought process. What is microgrid? Yes. Anybody can just share your thought process. Yes.
Please, participants, we have spent almost 2.5 days and discussing microgrids. So please do respond.
So what is then I can share my views with you, so that we can, yeah. Some Nikita Malur, she has written, Nikita, number of units connected together. So any other answer? Any other? See, this is not a questionnaire round, but I want to interact with all of you. So therefore, very often I like to interact, listen from your side, and some suggestions also from your side. I like that. That interaction I like. It is not that continuously I keep on speaking. So any other, anybody? What is this microgrid term?
Can I answer?
Yes, yes, please go ahead. I'll be very happy to listen to you. Niti Desai.
Yes, ma'am.
Can you just
Microgrid.
introduce yourself? Can you introduce yourself first?
Yes, ma'am. I am Niti Desai, working with Government Engineering College, Godhra. And
Very good. You're in this electrical department.
I am working,
Maybe your voice is breaking, so you can
I'm doing my PhD. Yes, ma'am. Yes, ma'am. Okay, so we can say microgrid is a combination of different energy sources. We can say both it can be renewable also and non-renewable also. And it is capable of operating in isolated mode
hmm,
as well as
grid connected mode. Good.
connected to the grid mode.
Mm-hmm.
And
Good, good. Thank you, ma'am. Yes, ma'am, your voice is breaking. No issue. I got your answer. I got your point. So thank you so much. It is also good that you have participated and share your views. So one also point I received, Swati Krishna, a group of interconnected loads and distributed energy resources with control systems. Yes, these all are correct thought. Very correctly, all of you said. So I'll just share quickly that what is microgrid. So that is those what I am going to share. This is almost aligned in the same direction. So this micro word means what? Micro means 10 to the power minus 6. And our Indian grid context in Indian grid capacity goes in the range of gigawatt. If I'll ask you what is the Indian grid capacity, so we'll not say in megawatt or watt. We will definitely say in the gigawatt. So when this gigawatt energy is multiplied with micro 10 to the power minus 6, so it comes to be 10 to the power 3 kilowatt. So that means it is very simple. The grid which handles the power in the range of kilowatt. So in according to IEEE standard, the handling capacity of microgrid is up to 50 megawatt. Now I came to know this is also extended up to 100 megawatt. So that means if the grid which has a capacity of handling power up to 100 gigawatt, understand, so 100 megawatt. When we'll talk about microgrid word, suddenly it should come to our mind, what is the power handling capacity? That is must, because for this reason only, before few minutes I said to all of you that the customers cannot speak to the utility has no control over customers. Then how the business will go, how the things will move in a proper way, how can we expect reliable power supply, how can you expect a very sustainable economic power supply things? That is not possible. So the customers are always dissatisfied. So let us say we are happy, we are in a campus life or some urban cities or rural city, semi-urban, where we have a lot of backup facility or some sort of energy crisis is not there. But in rural sector, it is very horrible. The power supply is very in a very nascent stage, and that is not properly electrified, or some places not taken, the maintenance is very poor. So how to take over it? So therefore this microgrid gives lot of hope for all of us. This microgrid has, definition is not enough. We have to understand its behavior, its characteristics, based on its advantages, how it will be helpful, what kind of hope or some sort of benefits we are going to get out of it. So this first and foremost definition, not definition, see, definitions are coming from the behaviors only. So first and foremost characteristics of the microgrid is, it is actually having a power handling, it has a power handling capacity up to megawatt, 50 megawatt. And next, second point is the voltage level. Up to what voltage level I'll call it as microgrid? Is it 400 kV, 1200 kV, 765 kV, or 132 kV? Because it is, these are our Indian standard voltage levels. like 66 kV, 33 kV, 11 kV, 400 volt. What is the level, voltage level? So it is also done this IEEE standard 1547 series. It has outlined all. I'm talking here with all of you the AC microgrid. I'm not talking for a DC microgrid. DC microgrid has different characteristic, different voltage level, power handling capacity, everything is different. So this AC microgrid, we can start from, we have different types of AC microgrid based on the voltage level. Medium voltage AC microgrid, low voltage AC microgrid, high voltage AC microgrid. So you can start from 66 kV onwards, 33 kV onwards, 11 kV onwards, 440 volt onwards. So when we land at 440 volt, we call it as low voltage AC microgrid, or 11 kV, 33 kV we call it, or 66 kV we call it as medium voltage AC microgrid. So the microgrid, of course, a 1200 kV system, I cannot call it as microgrid, isn't it? This is the transmission level voltage. So mostly the distribution side we are taking care. It's a good sign. Let me tell you, before few years I was going through one article that how poor it is, the maintenance of distribution side in India. Our transmission site is very smart, it is well taken, but however our distribution site is very poor, the maintenance is very poor, supply system is very poor, and how the government will take step towards it. I was reading before 8, 9, 10, or 12 years something, but fortunately this microgrid has given some chance to all of us that our distribution site will be very smart very soon, and we'll also, fortunately, our renewables are going to be installed at the distribution site. Penetration will be from the distribution site. So this is a very good concept that microgrid technology enables us to integrate the renewables at the low voltage level with a low power capacity, handling capacity, and a very small reason. You see, within this our IIT Roorkee campus, I can see what is the, you know, yes, Swasti, somebody has asked me in the chart, is there any standards that specify the power capacity of microgrid is 50? Yes, IEEE standard, you can just download or you can go through the IEEE site 1547.12.9. There is a series of standards for AC microgrid, because AC microgrid is a well established technology for last 20 years, 30 years. Researchers are doing in this front, but however for DC microgrid, the standards are not that clearly defined, but still we are struggling for that. Researchers all over the world, they are struggling for DC microgrid standards. But however, this for AC microgrid is a very well proven technology today's date. So that the standard you can write IEEE 1547 series, and there it is mentioned very clearly 550 megawatt. But I came to know from one of our panel discussion that this is also extended up to 100 megawatt. So this is how the standards are specified, and it is C and IEEE. All the standards are not set just with a one-man contribution. It is a, there is always relaying groups, task force, and the IEEE committee members who decides, and from all the countries the involvement will be there. And there is also one smart grid federation, and there are so many forums at their international level, and how to decide the standards are done from there, and that is released on the IEEE side. And why I'm talking IEEE, because IEEE is one of the agency which decides the standards, just like IEC, IEEE, ANSI, so many other agencies are there who are authorized to bring the standards. And of course, you may say in India also we have certain standard of bureaus. They also decide to, depending on our network capacity and our scenario, population, demand, and all. That is also possible. At national level also we have some standards. Right. So I'm talking in global front. I'm talking because we have to fight. See, whenever I'll just, my researchers will upload some paper. So we have to upload the IEEE transactions. So there we cannot compromise that, okay, this is Indian standard, so you have to follow. But which technique I'm developing It is only helpful for India. It is not helpful for Europe. It's not helpful for Canada, for US. So obviously, so when some researchers, they develop some technology, that should be globally accepted. And even some hardware software platform we are developing, our proven technology, so that should be very, very competent globally, right? So this is how the first 2 points I said with all of you. This micro means 10 to minus 6, and in the grid, national grid capacity, gigawatt 10 to power 9, so multiply it, it comes down kilowatt. So what is the range? Around 50 megawatt. We are talking today's date voltage level, mostly in the low voltage we are trying to have some microgrid concept. And second point, what one of the ma'am, she said that this is the combination of renewable sources and the loads and the grid. In a very, see, the point wise, I like to always discuss everything in a point wise manner, so that of course what I'm talking to you, this is all abstracts of different connections. I'm not going to mathematics anymore, but however, I'm just coming to the introduction, as my topic title is Introduction to Smart Grid Technology. So I'm just giving some starting kickstart points to this particular topic. So this second definition, second behavior of the microgrid should be like this. It's an interconnection of distributed energy resources, loads, and definitely grid is there, grid. So I'll discuss you what is the difference between the renewable sources and the grid. The renewable sources, sometimes we confuse that it is only the solar, wind, biomass. Is it? No, the renewable sources, also the storage. Renewable storages are also the major part of renewable sources. So we should not forget, suppose some network has, let us say, rooftop mounted solar, but we don't have storage, we cannot call it microgrid. That is the point. So renewable sources includes the renewable sources, no doubt, and storage, and the loads, and the grid. So not necessarily that you may ask me, what is the difference between the grid and renewable sources? The grid is actually the conventional supply system. The conventional may be the coal-based generation, maybe large hydropower plants, right? So majorly in India, we are just dependent on two things, that is our coal-based generation and our grid, which is the main grid supply to my IITR distribution network. We have two major supplies, like main substation 33 kV to 11 kV substation. We are getting power supply from the northern side grid, and that is the hydropower plant grids. So similarly in Odisha, we have the NTPC, we have the like in Talcher National Thermal Power Plant. So from there, we are getting the main grid supply from the coal-based generation. Similarly, in the southern side, some places we have the nuclear-based power plants. So those are actually non-renewable source-based grid. The grid may be coal-based, may be hydro-based. Okay, so that is the grid, conventional. We call it as conventional supply system. There is no renewable concept. So, and loads. So now this is the second behavior. Third one, this microgrid should also, either it should operate in grid connected mode or islanded mode. So what is the meaning of that? Suppose my grid is not present. So my rest of the network, which I have shown in this picture, they're actually this right side is my microgrid, the box, rectangular box. And the left side is my grid, main supply grid. So transmission, distribution, then the loads. Now, suppose my grid is off due to some reason, some disturbance. So due to some shutdown or maintenance. So then my other side of my microgrid should be possible, it should be sufficiently enabled to supply power to the respective loads. So that is the meaning of this islanded operation. The microgrid should be enabled to supply the rest of the loads. But here, one more fact, let me tell you, in India, our microgrid is not capable of supplying 100% load to the respective 100% loads, because till this point, our renewable integration to the existing circuit is more or less than 30%. And few areas where actually all wholesome power supplies from renewables we call it as islanded. We call it as standalone mode of operation of the system. Standalone mode means the only and only the renewables or any other diesel generators, whatever the supply system we have, they will take care of the loads. So this is how the from my end this microgrid is defined in terms of its characteristics. And there are so many other behaviors, of course, depending on the types of microgrid. Like I'll tell you after onwards. Like we have army based microgrids, campus based microgrid. We have remote place based microgrids. We have community based microgrids. Depending on its use, its locations, the microgrid types are also different. Then we have also types of, like, that comes under the technicality, its planning and all, behavior operation. But however, initially, what is microgrid? These are the 3-4 points from my side. So this is how another term, very quickly it comes to us. What is mini grid? What's the meaning of mini grid? So this mini grid is a smaller version of microgrid, but it is a little different than microgrid, this mini grid. How? You can see this picture very clearly. I'm just enlarging this picture. If it is not visible, you please tell me. See this mini grid. So what is the basic difference? Who will tell me? If any one of you know it, from this picture at least can you say what is the difference between mini grid and microgrid? Yes. From this picture I have enlarged. I hope it is visible to all of you. Can anyone say from this picture at least what is the difference between this microgrid and this mini grid? Can you pick up any information from this picture, any one of you? Voltage level difference, Kanjal Solanki, he said voltage difference. Any one difference? Any other difference? Can anyone say voltage level difference? Kanjal Solanki mentioned. Solanki. Yes.
Agricultural processing facility.
Pardon? Okay. Yes. Any other point? By looking this picture, what kind of major difference you can see between this microgrid and mini grid? Yes. Okay. So now coming to this mini grid, what is this? You can see this picture quickly. There is no presence of main grid. There is no presence of main grid. Okay, so that's the basic difference between this mini grid and, yes, no dispatchable disease. Yeah, so it is also correct one. I think Swati Krishna, it is also a nice answer, thought. So the first and foremost difference between the microgrid mini grid is the main grid is absent here. There is no supply of main grid. It is self-sustained. It's a self-sustained network from the renewables and storage. Storage is must. Even microgrid storage was also there. Renewable was also there, but main grid was there. But in mini grid, the main grid is not present. So suppose I have seen in South Africa many small islands, small village areas mostly. This California University, they have taken some projects funds from their many companies, industries, because in outside in Canada, US, Europe, Australia, so Europe, so basically they take some projects from the industry and they did it some pilot projects, developed countries like South Africa or India, and they submit their results to them. And if some solution comes, so they will sell in the product, and the product from to the whole world. Okay, so that solution will be available to everyone. So I have seen they have California University, they have taken one pilot project. They have installed a rooftop mounted solar battery, and they have Here you see the solar, then multifunctional inverters. Inverters, why? Because the battery solar has the DC input, and the AC will go to the transformer. The transformer will step up or step down the voltage according to the residential areas, agricultural area, because this is a village area. So where major loads are agricultural loads and the residential loads. Okay, so there is no industrial loads. Even we cannot meet also industrial load demand because industrial load demand is high. At least some residential DC loads, DC fans, Xeroxing facility, internet, emergency hospital areas, some school areas, like that. And agriculture like motors, some, these are all AC loads, not DC. So therefore, the red lines here you see AC currents, and the green one is here the DC currents. Okay, so this is how. But of course, here the one main constant in mini grid, that we cannot expect that our power supply will be 24/7. If the power supply, suppose daytime the solar is there, it is fortunate. The source, the energy will be stored for night time in the storage device. Night time, at least in every village household, they'll get one bulbs glowing on. Okay, their kids can do something, or they can do something. Okay, household works. So an emergency loads like agricultural facility for the agricultural process, they can do somewhat. So this is how this mini grid concept, and this mini grid power ratings are below 15 megawatt. The United Nations Framework Convention on Climate Change, UNFCCC, defines. This is one, you can write down this forum, United Nations Framework Convention on Climate Change, UNFCCC, defines a mini grid with a power rating below 15 megawatt and disconnected from the larger electric grids. So the larger electric grid is nothing, that is a main grid. Okay, so this mini grid, uh, this is how the things mini grid operates, and it can also connected less than 11 kV voltage level, and it involves small scale electricity generation. And sometimes, see, actually in these areas, very rural cities, actually we target with mini grid where the diesel generator may or may not be possible. So therefore I said the power supply is not continuous. Okay, they're basically isolated from the national electricity transmission network. Now, after this, then quite interesting one, what is nanogrid? Okay, so this nanogrid word is very convincing for all of us, but it is in a very nascent stage, new development nowadays. So people are very interested for this. We know everything, but we have to explore it, and we have to bring some standards and technology so that it will be helpful for the society. So this nanogrid is nothing when the size is further less than 50 kilowatt. As I said, in this mini grid the range is up to 15 megawatt here, you see, and this nanogrid the range is very less. Again, you can think of our building. So suppose you are sitting in the university, so that one department building itself will act like a nanogrid. A single household building itself is a nanogrid. Some kilowatt, some 100, 800 watt, or some 2 megawatt, 2 kilowatt, 3 kilowatt, a row of the loads which are connected to the feeder. So this is nanogrid. Okay, so residential small commercial site, here I have written in my PPT, so you can see the small residential small commercial sites are also called as nanogrids. Now this is a very quite interesting picture. See, this is your main grid, the rectangle. I mean, let us move from the in to outside. So this small blue patches and the light blue patches, they are nanogrid. And when many nanogrids are interconnected together, the dark blue patch is known as microgrid, and many dark blue patches are connected. Finally, they make the main grid. Okay, so this is how the building blocks of the smart grid. So the smart grid is nothing. The grid means the smart grid. So small nanogrids, then the microgrids, and then the smart grid. So it goes like this. So this is the solution. Actually, this is a big solution in front of us, that now I can just install the rooftop mounted solar. I can tap the power to my household If it is surplus, I can store in the battery, and next day I can utilize it. So this is a very, very good concept which is lying in front of us, right? So this is how this nanogrid looks like. We have a single home where we have non-renewable source. See, yes, one more point I want to clear with nanogrid, that this nanogrid has the connectivity to the main grid, but in mini grid there is no connectivity. Okay, the nanogrid sets a single building. The single building can get power supply from the agencies, the grid supply system, and also the renewable supply on the storage, everything. So this is how this nanogrid looks like. The blue portion you see, I have non-renewable sources means our main grid, energy storage. So these three are the supply sources. Now in the yellow sides, they are actually the loads, load 1, load 2 up to load n. And in between the red side is the nanogrid controller. So this is a model nanogrid I have shown you. But however, our rooms, our buildings are not made like this till this point, because this whatever I discussed with all of you, this is halfway. We have not reached the 100% implementation stage. So these are all halfway. Halfway means rooftop is solar mounted rooftops are available, storage is there, but we have made it successful with the controller, with the automatic process aspect. Those aspects are still pending. Still those are actually lying down. Few areas we have done it. So like in our department, I have seen if we'll move with the sensors, the light will be on, otherwise the light will keep on off. Unnecessarily earlier, throughout the night and day, the lights will be on, the energy will be wasted. So therefore we have kept a sensor. The sensor will sense the human body movement, and then it will just tell the light switch on, then the lights will be switched on. So this is one of the example of optimized energy utilization, and it is happening in an automatic manner. This is small example. Suppose I am sitting, I just forgot, I went to my office, I forgot to switch off my dryer or my washing machine or my lights or fans. So I have to do one command to my controller that you switch off all my loads. This is how a small example I'm talking to you. There are so many applications in different load sectors, starting from the residential, agricultural, industrial, then transportation is the biggest challenge now, the electric vehicle charging stations. So everywhere we can make it optimized power utilization. Okay, so this is how the red one, the gateway, and the gateway is the way where this particular home, the exchange of power, any information, communication, power, information, data, whatever you can say, you can exchange to outside nearby grid or your policymaker or to our utilities or to other loads, whatever we want, we can do by sharing the data. Right, so this is how this small structure of this nanogrid components. Okay, this is my grid. Okay, this is my grid. And after grid, we have a smart meter. I think all of you know this smart meter to some extent. You heard recently. I heard that some university they got some good funds to manufacture smart meter in India itself. We have like ABB, many companies they have already manufactured. It is not so difficult, but the smart meter. So now this is not possible anymore with the smart meter facility, where they cannot tap. Even though they tap it quickly, this message will come to the authority that there is some mishappening at this terminal, at this load end. Okay, so no way you can't, you can't just keep a cheating to the authority or utility or to the company, whatever you can say. So the smart meter has many features, which is actually the energy meter. It is going to be replaced by the energy meter, but it has various features. Okay, so The single phone, you can get all the information that your energy is available for this point. You can recharge your duration. Let us say you'll stay for 20 days, 10 days will not stay. So you have to recharge accordingly to energy supply. And if suppose you are not putting your bills in right time, so you'll be caught with a message that your availability of electricity is for these days left. So please submit your bills. So so many. This is small instance, small application. I said there are numerous technical application also. Automatically, the utility can control our loads with, of course, permission, not with without permission. And the loads centers, they can also control the utility supply. If I'm not satisfied with the supply, so I can always pick off the power supply from other agency. So there are so many things are possible by using this gentleman, that is the nanogrid controller. You can see this my PPT. There's a nanogrid controller which will control everything. In fact, the smart meter operation, then converters, PV inverters, then converters of my loads. So everything, the grid side information. So every information will be available in the nanogrid control center, and where I can do whatever the desired work I like. So these are some of the my first phase. I have focused on my smart grid definition. The second part I have discussed on what is microgrid, what is mini grid, what is nanogrid, and what is a control action in a nanogrid or microgrid aspect. So you can see like this, there are so many, nanogrids are connected to make a microgrid, and then they are connected to the the main grid. So this is how the evolution is going on, but you exactly what is our requirement. Slowly we are moving towards, like, we have military now is growing. One of my information I got from military base, that every military base, they are now enabled by solar. So campus institutional microgrid, as I said, remote off-grid microgrids, then community, commercial, industrial microgrid. So everyone is trying to push their information to a very, high information, and they're trying to have some sort of this microgrid concept in their areas. So this is how the two topics I have covered today with this assigned time. And I'll just to end off my talk with two more PPTs, which will be helpful of many of researchers who are present here. What I said, this microgrid, you can have solar, wind, you have loads, any sort of, this microgrid. I just said the safe side, the beautiful and the rosy cozy side of the microgrid. But however, when we operate it, there are so many challenges are coming up. Like first challenge, I'll tell you, this protection. And the protection of microgrid is very, very challenging. Stability of the microgrid is very challenging. And also this virtual inertia concept, generation control of the microgrid, controlling the converters of the solar or battery, and even the wholesome microgrid control is also very challenging. And other aspect of electronics, like how to design a good topology of converters for my solar, for my battery, for my electric vehicle, that is also challenging. And how to monitor the whole system, because let me tell you, we have PMU, phasor measurement unit, in the transmission line to monitor the health of the transmission line. But however, unfortunately, our distribution line is so neglected. As I was telling to you, I read one article from this electricity corporation site, that how we can monitor the health of the distribution sector as well. So that is also very much coming up, that we call as micro PMU. So how to install these micro PMUs? These micro PMUs are actually basically monitoring devices. It will just monitor the health of my microgrid system, and it will time to time inform to the operator. It will support the operator's awareness to take some further action. So these are some of the areas which are the focused areas, and sensor development, communication layer, the most important fact. Okay, so the communication layers, how to develop good communication, so that my controller, central controller or local controller, they'll speak to each other, and they can coordinate in manner, they can take some decision. So there are so many other aspects which with time, if I'll get some more chance, the next, if you'll meet together, then I can discuss more in detail of protection development strategy for microgrids. Okay, and few labs, let us some researchers, they have developed some strategy for defending or designing some problems or some solving some problems. Those problems should be solved in a HIL loop. We call it as HIL loop. What is that HIL loop? Your microgrid or system, whatever her design, it should run in this left side figure. We call it as real-time digital simulator. You see on the left side, and this digital real-time digital simulator is a very beneficial device which is available in the IIT Roorkee electrical department, and we have a facility to take, I mean, in this library you can do solar, you can do wind, we can do battery, even I found that electric vehicle also we can simulate. So all components of the microgrid smart grid environment, communication modules also available, PMU model also available, control blocks available, so sensors are there. So everything we can simulate as is a kind of smart grid microgrid environment. Then any signal, anything, if you want to, like you want to this thing, real time simulators. So then you have to then you have to take the data to this DS1104 board, and then you have to back the signal decision to the RTDS. Okay, so thank you all. We have a laboratory facility in IIT Roorkee. This is also one more lab, MP Varsity lab. So thank you all. So any questions, I'll be very happy to answer. Otherwise, we'll stop here. Yes.
Okay, please, participants. Please, if you have any question, Dr. Jena would be happy to answer your questions.
Yeah, so I'll be very happy if any question will be there. One question somebody has put here when I was talking mini grid, no dispatchable disease. Yes, this is also correct, because there we have only solar or some solar mostly, because in remote areas we don't have that facility to have tap the energy from the wind system. So mostly we believe on solar and battery system.
Any other question? As she has already mentioned while starting her talk that she would be happy to even receive some
Comments,
corrections. So even that is also welcome. So please, if you have any doubts, comments, clarifications that you need, you can definitely ask Dr. Jena.
Yeah, some Niti Desai, there is a question. Should nanogrid have a energy system always? Yes, it is. It is, the nanogrid is always connected to the main grid, and also solar, mostly solar battery, because we are making it at the residential level, mostly the commercial site level. So there we have always a grid reach. The grid supply is, suppose in our house we have a main board, MCB. So before that there is a supply from the main grids, and also there is a supply from the rooftop mounted solar and also battery. So therefore the energy supply is always there in nanogrid. So issues of interconnecting microgrid with utility grid. Yeah, so honestly, there are so many issues. As why I said, while connecting this microgrid, nanogrid with the main grid, the first and foremost issue is the protection. This is actually our field. So we are working our lot many PhD scholars. You can visit our website at the publications. I request, if anybody is interested with any of the work, I'm there to share with you our knowledge, our database, or some sort of queries. So first and foremost issue is the synchronization process. And the synchronization process we have to take care. And after onwards, as far as the operation is concerned, the protection system should be relooked before connecting the renewables, because earlier the distribution network has a unidirectional power flow, no bidirectional power flow, no power circulation. The power was only from the substation to the load centers. Now the renewables are connected at every corner of the network. So the power flow can be in any direction. So you cannot control the power flow now. So therefore the devices which are installed, so they will see different levels of the current, different direction of the current voltage. So therefore the devices which are installed with the previous fixed setting, so they should be adaptive setting. They should operate in adaptive setting mode. That is a major challenge in protection. That is my field we are working. And there are so many other control strategy of the inverters. When the inverters are connected to the grid, the control strategy of the inverter of the solar or battery or the wind, they should be taken care fully. When the grid is connected, the control strategy will be something else. When the grid is disconnected, we call it as island net mode, the control strategy will be something else. Right? Yeah.
Dr. Jena, yes,
Which
one.
type of micro inverter, just read me, which type of micro inverter power topology we can use in microgrid and smart grid. So this is not micro inverter, the inverters, the different designs like ABB, GE, different company, they are making their inverters for the solar. There's a micro inverter, I understand. So size, depending on the size of the network power supply, the inverters are designed by the uh, different companies.
Yes, I would like to ask a question. As there is no clear distinction between the microgrid and mini grid, as far as sometimes it can be used interchangeably also. But altogether, the nanogrid is quite smaller in size. So, are the clusters of the nanogrid that form the microgrid, or that nanogrid should be treated separately than the microgrid?
No. The cluster of nanogrids are the microgrid, because this nanogrid and microgrid, they are of similar behavior except their power handling capacity. Let us say in our IIT Roorkee distribution network, we have different bhavans like residential areas and our academic complex, or our administrative complex. So together, if we'll take every complex as a nanogrid and we'll combine together, finally we'll get a microgrid.
Yes,
Right.
okay, yeah.
So they are interlinked with each other, and this is a very simple topology nowadays we are using. It is the actual networked microgrid topology. So
Yes,
network
yes.
means they're interconnected. Yeah.
Any other question?
Yeah. So thank you so
If there
much.
is no question, then we can wind up this session. Dr. Jena, thank you very much for
Thank you.
sparing your time from your busy schedule and sharing and discussing such an informative material with the participants. As you have discussed very clearly from the basics and fundamentals of the microgrid, mini grid, and nanogrid, and even you have touched upon the smart grids and the laboratory facility available at the IIT Roorkee. So I guess almost all participants would get benefited from this very informative session. Thank you very much, Dr. Jena.
Thank
On
you so
behalf,
much, sir.
yes, on
It is,
behalf of entire team and the Sarvajanik College of Engineering Technology, I'd like to thank once again.
yeah, thank you, sir. I should first thank to you because for giving this opportunity. If you could not have given this opportunity, I may not appear in front of all of you, right?
Yes, sure.
So this is a first and foremost, as I said, point wise, I mentioned this is my first point, that I am really thankful from bottom of my heart to your whole core team for this FDP team, and your the authority that giving the chance to me, and also the last but not least, thanks to all the participants. They're very patiently, they're sincerely listening to me. I could see this is the very best FDP program, I could say, from my side.
Thank you very much.
All are very interactive and answered. They participated, so I felt very much honored. So thank you so much, and it's a great honor to share our research with the colleges like you. It is actually the government is also saying to share whatever the progress we are doing in our
Yes.
front, that should be shared. Now recently I got a project from this core grant from ACRB. Okay, so there is a clause that SSR, scientific, scientific social responsibility.
Responsibility.
Yeah, so that is mandatory. If you are not doing those components, that are the 5 components, if you're not teaching, or if you're not sharing your devices, at least 8 colleges in our country, so there you are misutilizing, and
Yes, utilize.
so you're not allowed to next take some help from the
Yes, that is
government.
true. That is very true.
Okay, so
And
thank you so much.
we'll definitely be take the advantage, and we'll be in touch with you, madam. Thank you very
Thank you.
much once again.
Thank you so much. I hope for the best and the future also. I'll coming again and interact. Maybe from IIT Roorkee, if we'll handle something, we'll invite you all. Thank you so much.
Thank you very much, ma'am.
Thank you.
Now all participants, please fill the feedback form, and tomorrow we'll start the session at 9 a.m. sharp, not at 9:30 p.m., but we'll start the session at 9 a.m. start because of some restrictions and the time limitation of other speakers. So we'll start at 9 a.m. Dr. Bhavesh Bhalja will start from the IIT Roorkee, will talk on the comprehensive review of various techniques used for hybrid AC/DC microgrid protection with existing standards. Then we'll have a break from 11 to 11:15 instead of 11:30 to 11:45, and then we'll again meet at 11:15, and that session will be conducted by Dr. Ashutosh Giri from GEC Baruch on the role of intelligent techniques in microgrid. And then we'll have a lunch break from 1:15 to 2 p.m, and then at 2 p.m. instead of 2:30 p.m. we'll start our tomorrow's third session at 2 p.m, and there will be a 2 sessions probably. So one would be from 2 p.m. to 3:15 p.m, and the next would be 3:15 p.m. to 4:15 p.m. So Dr. Zakir Rather from IIT Bombay will be speaking about the inertia of the microgrid. So all tomorrow's lectures are very interesting, and for those who wants to work in this particular area. So I request once again to be on time, and we'll start the session tomorrow at 9 a.m. sharp. Thank you.